Welcome to a lesson with Dr. Powell. Let's talk about a way that we can find the slope of the tangent line of a curve that doesn't really look like a function. For instance, a circle does not pass the vertical line test. A circle centered at the origin with radius 1 can be written as an equation: x squared plus y squared is equal to 1. Now, let's think about this circle. It's actually made up of pieces of function. One function up here and one function down here put together to get the whole graph. So it's made up of two functions. Locally, that means if I'm anywhere on the curve, then what I have is I have a function relationship between my x and y values, which will satisfy the output of the function, and the x value itself will always satisfy this equation. Meaning that locally, no matter where I am on the curve, here or here, wherever else, both sides of this equation will be functions of x. So if I'm down here, I'm just choosing the y value that comes from right here, yet nonetheless, that put into place here, this right here is a function of x. And then this will be a function of x. And that happens because we're assuming that locally around that point, y is a function of x. So we can think of both sides of this equation as functions. So we can take the derivative of both sides with respect to x as follows. We have the derivative of the left side, thought of as a function of x because y is a function of x, is equal to the derivative with respect to x of 1. Derivative of this side is simple, 0. Now of this side, think of this y as being some kind of chunk squared, like a composition. You're composing it with y itself into it. So if we want to take a derivative of this, which can be thought of as this, we simply take the derivative of this part 2 times. Now what went into this? It was y, so y jumps in. Then that composition turns to a multiplication times y prime. Now here, take the derivative of x squared. That's simple, just 2x. So we get 2x plus 2y y prime on this side is equal to the derivative of that is 0. So we end up getting a relationship for dy dx, and it works anywhere, whether you pick this function down here or this function up here. And this is the relationship, it's that equation. So we could subtract 2x from both sides. So we end up getting negative 2x is equal to 2y times y prime, which I will write as dy dx. Okay, so then we can just divide both sides by 2y and get negative x over y. Woo. This is an equation for the slope of this circle at any point. For instance, if I choose the point right here, when x is square root of 2 over 2 and y is square root of 2 over 2, then if I want to know the slope of this point, I simply plug this x value and this y value into this equation here for dy dx. Notice I don't have to solve to write y in terms of x. I just leave it in terms of xy. That's just fine. So if I'm given a point on the curve, then I can plug these 2 points in here, and we end up getting negative 1 as the slope. Should make sense here. Just plug it in here just to visualize the algebra here. So negative 1 for the slope right here. Thanks for watching.